All right. So last time we talked about, we revised character arrays. We talked more about characters. We talked about the ASCII code and the decimal equivalent for each character, basically for each character on our keyboard. And we also talked about how uppercase characters have a greater decimal equivalent or have a greater ASCII code than, lowercase. I keep I'm mistaking them, but lowercase letters always have a greater ASCII code or decimal equivalent in the ASCII table when compared to uppercase letters. So for example, lowercase a has an ASCII code of 97, while an uppercase a has an ASCII code of 65. And we said that the difference between lower and upper is 32. And knowing that difference basically helps us when we want to convert or whenever we're working with characters. But here's the thing, I want to ask you, and I want to see what you guys think. If I want to compare, for example, two different strings, so we have string first and then we have string second, and we're going to ask the user to enter first and, we're going to ask the user to enter first and second. Okay, and I want us to write a piece of code that helps us figure out whether the first string is greater than the second string. But I'm going to give you a quick hint. So basically with strings, we can just compare them using the relational operators that we took early on in the course. So for example, if we say if first is greater than second, this will refer to the ASCII value or the ASCII code value of the first string and the second string. So for example, if first is greater than second, means that first has a greater ASCII value than second. And we're going to try this out now. So see out, so if first is greater than second, we are going to say first is greater. Okay, so this is just a quick review to what we talked about last time. And on the other hand, if second is greater than first, second would be greater. And the last, I'm going to go with else if, because if this was true, it means it doesn't have to go to the second statement, which makes it more efficient. And the last one would be if first and second were equal, we would say they are equal. So we're going to test this out. And I also want you to help me with another thing. When we test this code, I want you girls to help me figure out how we can find the ASCII code, the decimal number, let's say, or the decimal value of this string. So we're going to start with inserting ABC and hello. Okay, and we're going to run the code. So basically all this chunk of code is asking for us to do is to submit or like to enter first and second, which are strings. And if first has a greater value than second, it will print out that first is greater, second greater than first, then second is greater. And if they're both equal, then it would print they are equal. Now in this case, let's see what our code gives us. Oops, and that's my bad. Let's try again and see. So it tells us hello is greater, which means that hello, which is the second string, has a greater ASCII value than ABC. And I want you guys to help me figure that out. So how can we find the ASCII value of first and second and print them out as decimals? What do you think? We're going to stick with ABC and hello. And I want you girls to help me with that. So I'm going to erase this. And I want us to write a code that receives these strings from the user and then prints out the actual ASCII code or like the ASCII value / decimal equivalent of these strings. What do you think?
We see out first plus 32.
First plus 32. So what do you think that would give us?
So
tell me.
the value you were talking about.
Okay, so when we add 32, it's basically going to be adding 32 to the ASCII value. But we want to find the value. We're not going to edit anything, okay? So we're not going to be adding anything. But we want to find that decimal value, okay? So we don't want to edit anything. We're not going to add anything to these strings. We want to see the value, the decimal value of these strings. I'm going to give you a hint. So I'm going to try integer count 1. I'm going to give it an initial value of 0. And then count 2. I'm going to give it an initial value of 2. So count 1 basically counts the value of first, the decimal value of first, even though it's a string. And count 2 counts the decimal value of second. And I want us to print these values. This is a tricky one, but we solved something very similar to it last time. How do you think we can go through each and every character in first and second? What do we usually use?
A for loop.
Perfect, a for loop. Okay, help me out, Yasmin. So how do I start it?
And I equal to 0. Okay, I less than first dot length.
Perfect. Okay.
I plus plus.
I plus plus. Awesome. Okay, what would be our next step? So we have the count, okay, and I want us to find the decimal value of first. And if you remember, strings are very similar to arrays, meaning they are 0 indexed, and we can access each and every character through this for loop by using the index of each and every character. So what do you think would be our next step? I'm going to help you out.
We need to add the value of each character in the string.
100%. Perfect. Okay, how do we do that?
I don't know how to access each ASCII value of each character.
Exactly. So here's the thing. We are not required to, and I think it's basically impossible to memorize each and every decimal equivalent or like decimal value of each and every character. So we do not need to memorize these values, but all we can do is simply say plus equals. So we're counting decimal value of each and every character in first, right? So do you remember how we can add and how we can access the array, the string characters? How exactly can we access them? What do I have to put here? What do you think? How do I access each and every character? So for example, ABC, A will have an index of 0, B will have an index of 1, and C will have an index of 2. What do I do here?
Oi.
Hi, perfect, awesome. So what this for loop basically does is that it goes through each and every character and it adds the decimal value of each and every character that we saw last time in the ASCII table to the count variable that we initialized as an integer. Okay, so at the end of the day, when we print out the count variable, when we print out the count values, it's going to print the overall ASCII value of that string. Okay, and I want us to do the same exact thing for the second string. What do you think I should do? Basically the same thing.
Yeah, but we just change first to second.
Exactly. And we have to also change count, right? Since it's going to continue on count.
Yeah.
Exactly. Perfect. So count 2 plus equals second I. And by the way, we mentioned it a lot, but plus equal is basically a shortcut for count 2 equals count 2 plus a second I. This is basically a shortcut and I always like to use it. So our second step, our last step actually, will simply be to see out first, for example. And I'm going to see out the size, which is count 1. And see out second. and count. Let's see what the program gives us. We're gonna stick with ABC.
But
And
before, in the second we put first dot length. We didn't.
exactly. Perfect. Thank you, Zaha. Yes, 100%. Awesome. Thank you, Zaha. So let's check string, count 1, count 2. I think everything looks good. Let's see. Awesome. So ABC has an ASCII value of 294. And I don't know if you remember, but A, and you're not supposed to memorize that, don't worry about it, but A basically has a value of 97. So 97 plus 98 plus 99 will give us 294. And hello gives us 532. And that's why our previous program gave us hello. It basically said that hello is the greatest, has the greatest ASCII value. So I wanted us to go through this example because when I say largest, I do not mean length of each and every string. Okay, in this case, yes, hello would also be greater since hello has 4 characters and ABC has 3 characters. But when I say largest, I am referring to the ASCII value of each and every string. And again, I wanted us to go through this because we are going to be solving a nice, slightly tricky question right now, actually. So that's basically a synopsis of what we discussed last time. We talked about characters, we talked about the ASCII code, and we talked about the ASCII table and how we can manipulate and how we can work with characters and strings. Okay, so I want us to move on to the code forces question that I really like. I really like this question because it's a little tricky, but it's really fun. And it's called string task. Okay, so let's read it together. So Petya started to attend programming lessons. And on the first lesson, his task was to write a simple program. The program was supposed to do the following. In the given string consisting of upper and lowercase Latin letters, it deletes all vowels, inserts a character, which is this period over here before each consonant, and replaces all uppercase consonants with corresponding lowercase ones. Okay? So it's telling us that vowels are A, O, Y, E, U, and I. It's counting Y as one of the vowels, and the rest are consonants. The program's input is exactly one string, and it should return the output as a single string, resulting after the program's processing the initial string. Okay, so help Petya cope with this easy task. All right, awesome. So there are specific rules we have to follow. And we have to follow these rules and write them using C++ and using what we talked about right now and what we talked about last time in our last session. So the question basically asks us to delete all vowels and insert a character, which is this one, which is the period, before each consonant and replace all uppercase consonants with corresponding lowercase ones. All right, so here in our first test case, it gives us the word tour, and tour has 2 vowels, O and U. What it basically does is that it puts this character that it gave us in the question before T and prints period before R, because these 2 characters are not vowels, and we are supposed to erase and remove all vowels from the original string. And in the second test case, if you notice here, C is uppercase, and the question asks us to make sure that all uppercase letters are converted to lowercase letters. All right, so here it removed all the vowels, it converted the C into a lowercase letter, and this is basically the resulting string, and so on and so forth. Okay, so this is an easy question, but we have to follow all these rules and in order for us to submit and get our answer to be accepted. So what do you think would be our first step? The easiest step?
We need to scan the string, CN the string.
Yeah, So let's say string S, for example. Okay, it doesn't matter. We can name whatever. We can name the string whatever we want. And as Yasmin mentioned, we have to, of course, receive the string from the user. Okay, awesome. So we have to delete all vowels, insert a character before each consonant, and replace all uppercase consonants with corresponding lowercase ones. Awesome. So you're gonna help me. What do you think we should do?
A for loop to access the string.
Awesome. Okay. So for
And I equal to 0. I less than s dot length. I plus plus.
I plus plus. Excellent. Okay. Our next step. So we are accessing each and every character in this string. Now, I personally prefer that we check each and every string before we start with this, or like before we end up outing the statement to the user. Okay, so what did the program ask us to do? It asked us to delete all vowels, but it also asked us to replace all uppercase with corresponding lowercase ones. So do you remember how we used to do that last time? Okay, here's a hint. So we said that the difference between uppercase and lowercase letters is 32. And uppercase are always smaller than lowercase letters in the ASCII table. So what do you think? I'm gonna help you out. Okay. What do you think our next step should be?
SI is less
Okay.
than.
Yes.
Can you please put the table so that I.
Here's the thing, you really don't need the table, okay? But all you have to know is that the difference is 32. But Zaha, you don't need the table here, and you're almost there. So what did we used to say? If it's an uppercase, then I have to convert it to lowercase.
Less than small a, small letter.
Okay, you're almost there. But are we converting to uppercase or lowercase? We want to convert uppercase to lowercase, exactly. So we're checking if it's uppercase, right? So we're checking if it's uppercase. And if it's uppercase, I have to convert it to lowercase. So do I include the lowercase a here or an uppercase a here? What do you think? So
Uppercase?
yeah, an uppercase, exactly, awesome. So we have to include an uppercase a because we are comparing. So we are, we're making sure that every single character in string S is lowercase because that's basically what the question asked us to do. We have to replace each and every uppercase letter with a lowercase in order for us to print this out. Okay? So we're almost there. So what did we used to do? Do you remember? We actually solved something very similar to this last time. So if S of I is less than or equal to uppercase A, and then what?
And SI is greater than or equal to uppercase Z.
Excellent. Okay. So in this case, what do we have to do? What do we have to do to S of I to convert it to lowercase?
We need to add 32.
Absolutely. I have to add 32. Because again, uppercase letters are always less than. Their value is less than lowercase letters. So you have to add 32 in order for this uppercase letter to turn into a lowercase letter. Excellent. So we covered this rule. And now we have to figure out how we can print the string in this form. So we basically have to erase each and every vowel. We need to make sure that S of I is not a vowel. So this is the tricky part. I'm gonna help you out with another if statement. And we're almost done, by the way. We're basically 75% done.
If SI equals E, and then, or basically all the vowels.
Basically all the vowels. So we're gonna try or for now. Okay? So I'm gonna go with or, and then I'm gonna fix these, don't worry. Excellent. So it's E, A, O, I, and U. And then it also asked for us to check whether if it's Y or not, right? Since Y here is considered one of the letters we need to be aware of. Okay, awesome. So if S of I is E or A or O or I or U or Y, then we have to do something. There's a mistake here, and I want you girls to help me out. So we're trying to print the string without the vowels. Okay? There's something we need to fix. If S of I is a vowel, then I don't want you to print it. This is a tricky question, but we can solve it. What do you think? There are two things we need to fix. Any ideas? Okay, so I'm gonna help you out. I'm gonna help you out with one tiny step. So here we are trying to filter out the vowels. So if S of I is not a vowel, then I want you to print it like that. I want you to add this character and then print S of I. Only if it's not a vowel. Okay, so if it's not E, and if it's not A, and if it's not O, or I, or U, or Y, you have to make sure that it is not any of these. Then I want you to print S of I.
We need to add an exclamation mark.
Where do we add it, Yasmin?
Before the equal.
Exactly.
In
so,
the condition.
So it's supposed to be not equal to any of these. So if it's not equal to, and by the way, there are so many different ways to solve this question, but I think this is the easiest way. And it's basically to check if S of I is not a vowel, and if it's not, just print it out. Print period and then S of I. But there's one more thing. So I'm gonna try it out and we're gonna test it together. So if S of I is not a vowel, then see out character, this character, and then S of I. Okay? So we're pretty much done. There might be some stuff we need to edit. So let's try to copy this test case. Go to the text console and try to see what it gives us. We're gonna try all the test cases. Interesting. So it printed it out. It printed it out with the vowels. And it's not supposed to print it out that way.
And in the
Can you
condition.
say that again?
Yeah, in the condition, we can't say or, we need to say and.
Excellent. So why?
Because, okay, when we go inside the if statement, like in the example here, so like we go, it's not equal to E, then directly it's going to access the if statement. It should be also not equal to A, neither O, neither I. So like here, one condition is right. So that's why we access this if statement. But all the conditions must be right in order to access it.
Excellent. Absolutely. And that's why we need to use an and instead of an or. Okay? Because just like Yasmin said, if it's not an E, then that's fine. It can be an A, it can be an O, or an I, or U, or Y, and it would still print out the vowel, even though we're trying to not print out these vowels. And with the and, operator, as we discussed before, every single condition in this if statement should be true in order for us to enter and execute the code that's over here. So excellent. So here we made sure that it is not a vowel. Okay, but first we made sure that it's a lower, it's not an uppercase letter, because that's what they asked us to do. They asked us to make sure that it's not an uppercase letter and that it is not a vowel. So we made sure that it's not a vowel. We made sure that it is not any of these. And when we double checked, we would see out S of I and have this character come before it. So let's try again with the same input. We're gonna try with tour. All right, it's supposed to print .t.r. So let's try to run our code and see what it gives us. We're gonna try every single test case to double check. Awesome. So it printed .t.r. Let's try code forces. And code force is a good one because C here is capital. We have to double check and see if it converts our C or not. Interesting. Okay. There's something wrong we did over here. C over here is a capital C. So let's double check our code. Let's see. There's something wrong. What do you think? It's a very, very small thing. And I think that's probably me.
Shouldn't it be SI is greater than A, but
exactly.
less than
Absolutely. I think that's my fault because I'm pretty sure you said it, but I switched them up. I'm very, very sorry. Let's try it again and see. But I'm glad we caught it real fast. It's supposed to work now. Okay, awesome. So C, D, F, R, C, and S, and that's exactly how it's written over here. And let's try this one last test case, which has a couple of vowels here. It has a couple of A's. Let's try it one last time, and then submit our code and see what it gives us. Awesome. So it's .b, .c, and .b again. All right, awesome. So are there any questions about this was, I'm not gonna lie, this was a slightly tricky question, but I'm always proud of you girls. You never disappoint me. So all we did here was receive the string from the user. We check whether S of I is a capital letter, if it's an uppercase letter, and if it is, we convert it to lowercase. And we talked about this last time in our last session. And that's because the difference between uppercase and lowercase is 32 in the ASCII table. And then last but not least, we checked if S of I is none of these vowels, hence the and over here. And if it isn't, we would print out S of I. So let's try to submit our code and see. Okay, so, oh no, I have to enter again. That's fine. Sorry about that. We have to find it. Okay, I'm sorry, girls. I'm just gonna look it up real fast. So string, I think I can find it. What was the question called? String task, right? Let's try and see. Sorry about the fuss, girls, but sometimes when you open a tab for too long, you end up losing everything. Anyway, so sorry about that. So let's try to submit our code and see what it gives us. Let's hope it accepts our answer. It's in queue, but we did test our code and thankfully everything turned out well. So let's wait and see. But before that, because now we're going to be going for something completely different. We're going to be talking about a completely different topic. So if there are any questions about strings or characters, please let me know so we can cover them now and so we can answer the questions now. Sometimes it takes some time. I think that's my bad. I think my internet connection is not that great, but that's fine. So we are going to move on. We're going to check it again and see later on. But for now, we're going to move on to something really, really cool. And it's basically 2D arrays and nested loops. So we talked about arrays before. We talked about why we use arrays and how we can use arrays and how we declare arrays and all of that. So for example, we can have an array called array and give it a value of 5. And we can, We can include 5 values. We can say 1, 2, 3, 4, and 5. And if you don't include these values, the rest would be zeros. Or you can not include 5 and you can just include the size here. Or you can just receive the values from the user by using a for loop, if you remember. So basically, arrays help us store many different values of the same data type instead of manually having to declare and store a value. So for example, if you have 10 or 100 or 1,000, for example, variables of the same data type and you want to store them in one array, it's so much more efficient to just use an array instead of manually declaring all these different variables. So arrays really help us with that. And since with variables, we can only store one value in a single variable, arrays can help us store many different values in a single array. Okay, awesome. But little did we know that there are different types of arrays, and we can have 2D arrays and we can have 3D arrays. So it's not just always one-dimensional. We can have different types of arrays and we can have different sizes. So with 2D arrays, the difference here is that we take another square bracket. Okay, so we're going to start with square arrays for now. So with a square array, and I'm going to declare the size, I'm going to go with 2 and 2. All we have to do is open these two curly brackets, just like we always do with our normal arrays. But instead, in this array, in this 2D arrays, each element is basically its own array. I know this might sound a little confusing, but each element here will be taking 2 different values. In this case, since we have a 2x2 array. So, and I know this sounds confusing, but we're going to test it out now. So within a 2x2 array, think of it as a table, or think of it as a matrix, or think of it as rows and columns. So this first square is the rows, and the second square bracket has the number of columns in this array. So we're going to start with 1, 2, and then I'm going to give it another element and go with 3 and 4. So this is basically what I mean when I say each element is technically its own array in a 2D array. So here, think of this element as the first row and this element as the second row. So if we see out this array or see out this matrix, it's gonna look like this: 1, 2, 3, and 4. So this is basically a 2D array. We have 2 elements here and 2 elements we have 2 rows and 2 columns. And if we, for example, decide to increase our array and go with a 3x3 array and include another element, which also happens to be basically an array, and say 5 and 6. So here it's not a 3x3 array. Here it's a 2x3 array. So if we wanted a 3x3 array, we have to have 3 elements in each array element over here. So in this case, this would be a 3x2. Which would be 1, 2, 3, 4, 5, and 6. So always think of this part as the rows and this part as the columns. So we have 3 rows over here and 2 columns. Okay? So I actually wanted to show you a really cool diagram that basically sums all this up. So this is a 3x3 array. We have 3 rows and we have 3 columns. Okay? So row 1, and also with 2D arrays, we also follow the 0 index. So with row 1, the value here has a 0, 0 index. Okay, and the value over here has a 0, 1 index and 0, 2 index in the third value of the first row. So the first row, the value over here, the first square bracket, which stands for the row, will be a 0 value. It will have a 0 index. However, in the second row, which has an index of 1, it's going to have an index of 1. And in the third row, it's going to have an index of 2. However, with columns, the first column is going to have an index of 0 in the second square bracket, and a 1 in the second square bracket in the second column, which has an index of 1. And last but not least, column 3 will have an index of 2. I'm going to try my best to draw it now. I'm not a great artist in any way, shape, or form, but I'm gonna try my best to figure it out and draw it on paint right now to like clarify everything. But here, for example, if I wanted to access the first element, so if I wanted to access 1, I would see out ARR, which we called our 2D array, and I would give it a value of 0, 0. Okay, so let's try to run our code. Basically, all I'm doing here is I'm trying to access the first element of the array, which has a 0, 0 index. It's supposed to print 1. So this is very similar to what we used to do before. We always used to write the name of the array, and then using just one square bracket, since we used to work with 1D arrays, we would include the array index. But in this case, there are 2 indexes that you have to worry about, which are basically the rows and columns to make it easier. I want someone to help me. So how do you think I can see out this value? What do you think? What do you think would be, how do you think we should set the indexes over here? What if I wanted to print 2, for example?
0, 1.
0, 1, excellent. Because 2 is in the first row, okay, but it's in the second column. All right, so does that make sense? Let's try to run our code and see. It's supposed to print 2 on the console. Awesome. So here stands for, this square bracket stands for the rows, and the second square bracket stands for the column. Okay, I want you to help me out. What if I wanted to print 3, for example? What should I change over here? 3 is in the second row and the first column. What do you think?
1, 0.
Awesome. 1, 0. Perfect. So how do we read this? We read this as second row, first column. Okay, let's try to run our code and see. It's supposed to give us 3. Let's see. Awesome. Okay. So this does get a little confusing, but when we get the hang of it, it's super, super easy, and we can have so much fun with 2D arrays. And one last question before we move on to something else. How do you think I can print 6? I think 6 is a tricky one, and I want to print it right next to array of 1 of 0. How can I access 6? Can I help you out? So 6 is in the
1.
2, 1. Excellent. So why? Because 6 is in the third row and it's in the second column, and the third row has an index of 2 and the second column has an index of 1. So let's give it a shot and let's see what it gives us. So it's going to give us 3, 6. It's not 36, it's 3 and 6, but it shows that way because they're right next to each other. So here you can see it's 3 and 6. So if you remember, we used to access arrays. So if you have 10 elements, or if you have 100 elements or 1,000 elements, again, we can't manually access them. It's so inefficient and it's so time consuming to access each and every array element manually, right? And that's why with 2D arrays, we can use for loops as well. But the special thing about 2D arrays is that we have to use 2 different for loops, which makes it a nested for loop. So if I wanted to access each and every element and I wanted to print each and every element here in this array, so if I want to print the elements of the integer array over here, I would have to set 2 different for loops, which would give us the which would basically make up a nested for loop. So here we have the first for loop is gonna stand for the rows, which in this case are 3 I++. This is basically the same exact thing we used to do with 1D arrays. And for the second for loop, we will be accessing the columns, which in this case are 2. And the usual convention when it comes to nested for loops is to basically name the second integer j. And that's just a convention. You can name them whatever you want. But the convention is to usually name the first integer I and the second would be j. And in this case, j would be less than 2 since we have 2 columns and 3 rows. Okay. So here, I want you to help me out. How can I print, and this is a tricky one, but how can I print the array elements in this 2D array? What did we used to do back when we were working with 1D arrays? We used to
write the name of the array, and then with square brackets, we used to write I. But I think we should write I in J.
Absolutely, 100%. Excellent. So here, since we have rows and columns, we have 2 different values we need to work with. All we have to do is simply include another square bracket and write J. Okay, so what's gonna happen here is that this for loop is gonna fully execute before leaving the for loop and entering this for loop again. So in this case, if you want to print the array like this, what the nested for loop will do is that it will go through 1 and 2 first, and then leave this inner for loop and go to the, and execute the second round of the first for loop, which is the upper for loop. And then it would print 3 and 4, and lastly, it would print 5 and 6. So again, think of these elements as separate rows. Okay, so it's going to print every row. It's going to print rows at a time. All right, so it's going to print 1, 2, 3, 4, 5, 6. So again, it's going to be printing rows at a time. And just for the sake of, just for it to look nice and just for it to look like a table, let's say, I'm going to include an end line statement after the second for loop. So let's see what it gives us. It's basically printing the for loop, the array we have here. It's going to print 1, 2, 3, 4, 5, and 6. And if I wanted the space between each and every element, all I can do is simply add a string. It's basically an empty string with a space over here. It would make it look more organized, let's say. So it's going to print the same thing, but it's going to look a little more tabular, let's say. It's going to look more organized. So here it's printed 1, 2, 3, 4, 5, and 6. So this is basically how 2D arrays work. It's the same thing. It's just there's an extra value that we need to worry about, which is basically the columns. So to make it easier, think of these as rows and columns. 3 is the rows in this case, and 2 is the columns. And this is how the array basically looks like. It's a 2D array. It consists of rows and columns. We have 3 rows here and 2 columns here. So I want to try to make it a little easier. And I'm going to try my best to draw, although, again, I am a terrible artist, but let's see. So basically, I'm going to draw a 3x3 array. So what we worked with was a 3x2, but now we're going to work with square arrays, or like square matrices, let's say. So all we have to do here is draw 3 rows. So these are rows, and 3 columns. And this is a square array. And in order for us to figure out how the nested for loop works, we're basically going to be doing the same thing as the table over here. Okay, so basically, to make it easier, we're going to go row by row and column by column. So this is our first row, and I'm going to give our first row 0, 0, 0, since we always start with 0. C++ and every other programming language is 0 indexed. So this is our first row, and our second row is going to be 1, 1, 1. And our third row is going to be 2, 2, 2. However, when it comes to columns, it's basically the same exact thing, but it is vertical instead of horizontal. So for our first column, it's going to be 0, 0, 0, 1, 1, 1, 2, 2, and 2. Okay, so I'm going to try to change the color. And I'm going to separate these.
Farah,
Yes.
are you sharing your screen? Are you
Oh my
drawing right
God, no way.
now?
I totally, can you see it now?
We can see the picture of the column 0 and row 0.
Okay, so can you see like a paint? Can you see a
No.
paint window?
No.
No, okay, I can't believe I've been sharing everything without showing you girls. Can you see it now?
Yes.
Okay, awesome. I'm very sorry, girls. So basically all I did, you know what? Should I do it again? I mean, it's fine. So this is basically what it is. This is basically what 2D arrays are. This is a 3x3 array or 3x3 matrix. And all I did here was set each and every index. So for rows, we go horizontally. So we go horizontally like that. And with columns, we go vertically. Okay? So to make it easier, this part is basically the I part. And then J and I and J and I and J. Okay? So to make it a little more clear, we are going to try to solve a couple of questions and like solidify. Hi, Chris. So we're going to solidify our knowledge in 2D arrays and how 2D arrays are basically programmed. So I'm going to stop sharing for a second and go back to our screen, our original screen. So basically, this is how I'm going to keep this integer array. Also, I'm very sorry, girls, and thank you, Yasmin, for letting me know, because I've been like talking to myself for 2 to 3 minutes straight. So thank you for letting me know. And I'm very sorry about not sharing it earlier. I completely forget about that. Anyway, it's fine. You didn't miss out on anything. All I was trying to do is to show you how the index basically works. It's the exact same thing as this table. So we go horizontally for rows, vertically for columns. And columns are J in this case, and the rows stand for I, or like I stands for rows in this case. Okay, so I want you to help me create a 3x3 array. Okay, and I want us to ask the user for the array values. Okay, so I am going to see out a prompt. Please enter 3x3 array values. Okay, so what would be our first step? How do we access 2D arrays?
For loop.
Awesome. So how many do we need in this case? We're going to be needing 2.
2. Yeah.
So can you help me out?
Yeah,
With
I
I
equal to 0.
Mm-hmm.
I less than 3.
Awesome.
I plus plus.
I plus plus. Okay. And for the second for loop.
4 and j equal to 0, j less than 3, j plus plus.
So, okay. And all we have to do is simply receive the information from the user. R of I and another square bracket where we include j. Okay? So the first one, it's going to be I equals 0 and j equals 0. So it's going to take the first value. This is a 3x2 array, but that's basically the same concept. And for 2, I is going to be 0 and j is going to be 1. And for the third element, it's going to be I equals 0 and j equals 2, just like we can see over here. Okay? And then I want us to print out the information. So all we have to do is simply copy the for loops and just alter this into cout. And to make it look a little more organized, I'm going to add some spaces and end the line after each and every row. So basically each execution here executes or prints out a row. And that's why we have each and every row on a different line. So let's try to execute the code and enter everything we need to enter. So it's a 3x3 array. And before I enter a 3x3 array, how many values does a 3x3 array include? How many elements are in a 3x3 array?
9.
Absolutely, it's 9. So how did we figure that out? All we did was multiply the rows by the columns. And in this case, we have 9 different elements. So we have to include 9 different elements. So I'm going to go with 1, 2, 3, 4, 5, 6, 7, 8, and 9. And it's going to print the array just like so. Okay, awesome. So I want you to help me out. We are gonna stick with this question as well, but I want us to add 2. I want us to add 2 to each and every array element. So if we enter 1, 2, 3, 4, 5, 6, 7, 8, 9, I want it to print 2, 4, 5, 6, 7, 8, 9, 10, 11. How do you think we can do that?
I'm sorry, can you please repeat the question because it kind of lagged?
Oh, sure. So all I want us to do is simply add 2 to each and every element. So instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, I want us to print 2, 3, 4, 6, 7, 8, 9, 10, 11. So I want us to add a value of 2 to each and every array element. How do you think we can do that? Super simple. What do you think?
I think we should, like, where the mouse is, we just like add +2.
Just add +2, exactly. That's all we have to do. And if we wanted the array to permanently be 2, well, technically not permanently, we can edit it whenever we want, but we can say array of I, array of j plus equals 2, and C out array of I and array of j. So I entered C out end line, so it would give us a space between each and every array here, or 2D array here, and just so the output can be clear. So I'm going to enter the same exact values. I'm going to enter 1, 2, 3, 4, 5, 6, and 7, 8, 9. Did it take that? I think it did, but the cursor isn't working. Oh no. I don't know what's wrong with the compiler. Is it the compiler or is it my internet? I'm not sure. Let's just try one last time and input the values again. So 1, 2, 3, 4, 5, 6, it's fine. 7, 8, 9. So there you have it. Oh, by the way, even if we enter them all at once, of course you have to have spaces between each and every element, since if you don't, it's going to take it as an integer. But if you include them all at once, that's totally fine as well. But here it printed exactly what we wanted. It printed 3, 4, 5, 6, 7, 8, 9, 10, and 11. And if I wanted to multiply each and every element by 2, all I have to do is simply change the arithmetic operation to multiply. If I want to divide, I divide. If I want to subtract each 2 from each and every element, all I have to do is simply change the arithmetic operations. So let's move on to something a little more difficult. And I think we're going to keep this session short and sweet, but I want us to solve this question before we leave. Because this is a really, really fun question, and it requires a little bit it's a tricky question. And we're still going to be working with square arrays. Now, a diagonal is basically these values. So we're going to be working with square arrays in order for us to find the diagonal. So here, the left diagonal is 3, 7, and 11, and the right diagonal is 5, 7, and 9. So left, obviously because it starts from the left, so we're starting with 3, 7, 11, and then the right diagonal starts from the right, so it's 5, 7, and 9. It's basically the values in the middle of the array or the matrix of the 2D array. So here's the tricky part. I want us again to receive a 3x3 array from the user, but I want us to find the sum of the left diagonal and the right diagonal. So this is a tricky question, but I want us to try our best and solve it together now. So I'm going to start with the first step, and I'm going to say left, and I'm going to give it a value of 0, and integer right, and give it a value of 0 as well. Okay, so we're going to stay, again, we're going to stick with 3x3 arrays. We're going to ask the user for a 3x3 array, and then we want to print out the value of the left diagonal, the sum of the left diagonal, and the sum of the right diagonal. So let's start with the left diagonal. So I want us to find a way to find the sum of 3, 7, and 11. Okay, so what do you think I should write? How do you think we should code this in order for us to get the right answer? So let's go back to here. This gives us a big hint. So the left diagonal is this element and this element and this element. What's so special about the left diagonal? What do you think? What do you think is similar between the values of the left diagonal? Zahar, are you trying to? I can't really hear you. Can you say that again? Or if you want, you can write it on the chat.
Can you hear me now?
Yes, yes.
Okay, so it's basically 0, 0, 1, 1, 2, 2, or like the same number for both.
Awesome. So what are these numbers? In the for loop, how do you access?
It's the I and the J.
It's the I and the J, exactly. So in this case, the left diagonal is basically when the I and the J are equal, right? Since as Zaha mentioned, we have 0, 0, 1, 1, 2, 2. So how do I code this? You're gonna help me out. What do you think? We're trying to find the sum of the left diagonal.
If I equal to J.
What would I do then?
This is the left diagonal, right?
This is the left, yes. So we're starting from here.
So left plus equal array ARR
Amazing.
IJ.
Absolutely, perfect. So this is very similar to when we used to solve the sum questions. Like we used to say sum plus equals array of I, or count plus equals S of I, or whatever. But in this case, we are trying to find the sum of the middle of the diagonal values. And in this case, we are working with the left diagonal since we are starting from the left. So when I and J are equal, which means we are working with the left diagonal, we are going to be adding the elements in these spots. Excellent. Okay, so what about, and this is a little, it's a little more tricky, but what about the right diagonal? So we're starting from here. We are starting from x0, 2. What's so similar between these three? What do you think?
Every time we add +1 for the rows, and for the columns we subtract by 1.
So that's a good observation. But so what do you think? You're getting there. You're on the right track. What do you think is similar between each and every one? That's what we want to try. That's what we want to figure out. So here in this case, it's when I and J are equal. But what about here? What's similar about the values of I and J? What do you think? So I'm going to give you a hint. 2 plus 0 is 2. So I plus j in this case is 2. 1 plus 1 is 2. And 2 plus 0 is 2. What do you think? I just gave it away.
If I plus j equal to.
Exactly. If I plus j equals 2. And in this case, it's 2 because we are working with a 3 by 3 array. But if we were working with a 4 by 4, it's basically going to be size minus 1. Okay, so if we were working with a 4 by 4, it's going to be if I plus j equals 3. And if it's a 5 by 5, it's going to be I plus j equals 4. Excellent. So, and what's wrong here? Should I keep this way? And this is from the basics. Should I keep I plus j equals 2?
Equals.
Excellent. Since we're not assigning here, we are comparing. Excellent. So in this case, we would simply do the same exact thing, but find the value of the right diagonal, or the sum of the elements in the right diagonal. Excellent. So all we did was simply go back to the table and figure out the similarities. So here in this case, if we're counting the left diagonal, I and j are equal. However, in the case of the right diagonal, where we start from the right, I plus j are size minus 1. And size minus 1, again, because we are working with with the 0 index. Okay, so our last step, just to double check on our work, would be to see out left diagonal, which is the sum of the left diagonal, and line, see out right diagonal, and right. Oops. So this is and L, and there's a missing L over here. Okay, so let's try to run our code. Basically, our program is going to ask us to input array values. I'm going to try 0, 1, 3, 5, 7, 8, and 9, 8, and 7. Okay, so it's going to print left diagonal 15, right diagonal 19. So 3 plus 7 plus 9 is 19, which is the right diagonal. Left diagonal is 1 plus 7 plus 7, which is 15. Awesome. So this is a quick introduction to 2D arrays. There are so many different uses for 2D arrays. This is just the basics. And this is just how we can use 2D arrays and how we can figure out the index of each and every element. And in order for us to access 2D arrays, we have to use nested loops. In this case, we used for integer I less than 3, I plus plus, and j as 2 loops. So this one is basically, so I is basically the index of the row, let's say, which is the first square, and j would be in charge of the columns, which is the second square. And that's basically how it is. So this was really fun. And this is just a basic introduction to the arrays. We are going to be working on, and we are going to be revising a little bit of 2D arrays next time. However, we're going to be working on something a lot more fun as well next time. We're going to be working on functions. We're going to be introducing libraries and built-in functions. We talked a little more about built-in functions before when we discussed strings. But next time, we're going to be talking about built-in functions and how we can make and construct our own functions in C++.